Well, we have another difficult integrand here, and we look, and we don't really see anything great going on here. What I do see again is here in the denominator, 1 plus something. And not only that, I want 1 plus something squared to get an inverse tangent, but then I look here at square root of s, and I realize that s is the square root of s squared. So now I think to myself, what if u equals the square root of s? Which of course would imply that u is just equal to s to the 1/2, and of course that means du is 1/2 s to the negative 1/2 ds. And so I look at that, and that means that if I multiply through by 2, that 2 du is equal to 1 over the square root of s ds. And I have right here 1 over the square root of s ds. So that is this. So I'm going to plug in 2u for that. So I have the integral of 2 du over 1 plus, and then like I said, this is u squared because s equals the square root of s squared. All right, take the antiderivative of that. That's pretty easy. That's just 2 times the inverse tangent of u, and that's going to be just 2, and of course plus c, but I can ignore the plus c since I'm going to put bounds back on it, 2 times the inverse tangent of square root of s, evaluated from, and we're going to go 0 to a, and of course we're putting a limit on this now. A goes to infinity. And so the limit as a goes to infinity of 2 times the inverse tangent of the square root of a minus 2 times the inverse tangent of 0, and the inverse tangent 2 times the inverse tangent of a, so that's just 2 times the inverse tangent of pi over 2 is of course pi over 2, and the inverse tangent of 0 is 0, and so 2 times pi over 2 equals pi. So our answer is pi, just like the answer key says.